And the session is very interactive. So I will assume that you will talk to me, you will put your conversations on the chat as well and have a discussion with me. I also need to highlight something about today's session. Today is not tutorials. Today is skills training, but based on some content around your QMI module. So it's not going to be a diverse thing. It's just those who have been part of my tutorial sessions before, you will think, oh, I don't know what now is happening in the QMI. No, because today is not tutorial session. I hope you will enjoy today's session as well. I just want to also join on my phone so that I can see what is happening on the chat. And I hope you brought your calculators with. And lastly, if you have any issues or technical issues or anything you want to get hold of UNISA Cape Town, that is the email address you can use, ctandtat@unisa.ac.za. At the end of the session, I will show you where the feedback form is. Please make sure that you complete one. For every session that you attend, you need to make sure that you complete the feedback form. And yeah, let me give you this 5 more minutes, 2 minutes, just talk to me. What are your expectations for today's session? I already have one person who sent me a message earlier at 5. They've never done maths before. So about the others, so that I know who am I assisting today. So let's have this chat. Feel free to open up your mics and talk to me.
Hello.
Hi.
Hi. This is Roxanne. I'm the one that sent the message earlier on that said I haven't done maths before. So I'm quite anxious. I don't know what to expect. I think anxious is an understatement. I try to read through the study guides, but in all honesty, I'm feeling quite lost and extremely confused. I just have honestly no idea what is going on at all.
Thank you, Roxanne. Anybody else who wants to share? I don't have answers, but anybody who wants to share? Why are you here today? What do you expect? What are your expectations?
Hi, Lizzie.
Hi.
It's Candice here. I registered quite late because I needed to wait on my exam results. So I only registered Thursday night, last Thursday night. And now my first assignment is due tomorrow. And there's no way in such a short time I could have gone through over 200 pages of my textbook. And I'm feeling very overwhelmed, just like Roxanne, because I feel as if I've been set up for failure, and I don't know if I'm even going to pass that paper.
Okay. Did you guys receive an extension on that exam, on that assignment? Sorry. Is that the due date with an extension?
Apparently, the first due date was the 11th, I think, and it was extended to the 25th. But I think that was just an extension anyways. It wasn't specifically to the students who were waiting on their final results. So when I registered, I only found out, okay, it's been extended to the 25th, which is tomorrow. And I mean, I had other classes to attend as well. And so I feel like I'm dying.
No problem. I feel you. Anybody else who wants to share? 1 more minute. Anybody else? Nobody. Okay, so I had the two. Oh, anybody? You can go ahead.
Afternoon, Lizzie.
Hi.
I trust you're doing well, Lizzie.
Oh, thank you.
Yes, just giving feedback on the QMI. I actually really enjoyed it because it's basically like maths actually, and I actually went through my maths book before I started with QMI to just reinforce my brain again to get back onto track with your exponents and things like that, as it's in the first chapter of QMI. So I basically actually taught myself to learn the exponents and things like that also, and uh, the root, the square root, and everything in the chapter also. So that's
Okay.
my background of QMI.
Okay, so that means today's session you're going to help a lot. You will be assisting those who are stuck as well. Since you are now, um, you have went through and you understand a little bit, or you understand. Okay, cool, great. At least there is someone who knows. All right. If there is nobody else who is willing to share, it's fine.
So it's Mariska here. I just want to ask a question.
Yes.
Are we going to get printed study guides this semester at all or not?
Not because apparently printed material carry lots of viruses. I'm joking. I don't know. Those kind of questions. That email address that you see there, ct@unisa.ac.za, send your email there. They will respond. So I don't deal with administrative issues of UNISA, so they
Okay,
will be able to help you.
great. Thanks so much.
Thank you. All right. So let's help those who are doing math for the first time and those who are scared about the assignment. Unfortunately, today's session is not going to help much because I don't know what is inside your assignment. I don't have a copy of your assignment, so I don't know what is covered in there. However, at least after today's session, it will open up your mind and show you that this is actually not that difficult. This is actually very, very easy because the first chapter of your QMI teaches you the skills, and that's what I'm going to be doing today. We're going to go through some terminologies and skills and how to use some of the calculators to calculate some of the problems and do those. Okay, so let's get to that. That's my name. I hope everybody can see that. My name is Elizabeth or Lizzie. You can refer to me as any of them. You can call it out. During the session, if I am moving too fast and you are lost, please, if I don't see your question on the chat, you can just unmute yourself and say sorry, and then say what you want to say so that we don't wait long. And if you are stuck, please please ask for help. Don't just sit there and watch us and listen to us talk, 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 talk. But I expect you guys to also participate. If you are lost, ask questions so that we can help you. So how I set up today's session, I can see there I have my times wrong, but anyway, we're going to do working with numbers, then we do the powers, and I think actually we do the ratio and the proportions. I need to update my slides. Okay, so the first component, which is what we're going to be doing, which is part of your module, is working with numbers. And that's what we are unpacking today. By the end of the session, you should know how to round off, how to use priorities, how to do powers, how to do roots, and how to calculate ratios and proportions. So when we talk about maths, it means we're using numbers. Therefore, it means we need to understand some of the terminologies and their properties. For example, when we talk about math, we talk about sets, and sets are just collection of objects that we are able to count, and it can be denoted by those curly brackets. For example, for natural numbers, which we are able to count, like 1, 2, 3, 4, we can put them in a curly bracket, and that forms a set of natural numbers. We also get what we call whole numbers, and a whole number is all the natural numbers including a 0. We also have integers. Now, in this module, you are going to use integers more often. And integers are positive and negative natural numbers, which 0 is in the middle of those. And also, you need to also learn how to apply the basic operations on these integers as well. Then we also have rational numbers, and rational numbers can be expressed as a ratio. So it means a rational number can be a fraction, or they are called fractions. Those are the rational number. And then we also have what we call irrational numbers. And irrational numbers in your module, we only use the root. They are also pies, or you also go in and use the pies at some stage when we do the areas, we calculate the area of a circle, we use a pi. And a pi is an irrational number. And a square root is also an irrational number. So it means today's session, we're going to be using all of them because we're going to be looking at integers, we're going to be looking at rational numbers and irrational numbers. And real numbers are all numbers associated with a number line, because you can put all the numbers on a number line, especially the integers. And also the rational numbers, you can also put them on a number line. Okay, so in a nutshell, what did I discuss? I told you there are what we call natural numbers, which includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which are numbers that you can count. We also spoke about the whole numbers, which also are part of the natural numbers, and they include 0. And we also spoke about the integers, which are the decimals. Oh, sorry, integers can be negative or can be positive numbers. And we also discussed the rational numbers, which can be irrational numbers and rational numbers. And we spoke about rational numbers. They can be fractions or decimal, because a fraction you can divide and it will give you a decimal number. And we're going to learn how to minimize the number of decimals that we have when we apply the method of rounding off as well. And that's what we discussed earlier on. So now, how do we then do an addition and subtraction, which are your basic operations on your integers? Now, to do this, easy. If both numbers are negative numbers, like -8, not -8, like a subtract 8, but this is a negative number. If I have a negative number and I subtract 2, the number will be a negative, because it will be as if like you are adding the two numbers together. So a negative and a negative will give you a negative number when you are adding or subtracting the numbers. When one sign is positive and one sign is negative, then when you subtract the numbers, it will take the number of the bigger number. So for example, if I had 8 minus 2, 8 is positive, therefore it means the answer will take the sign of the number, and the sign of the number is positive, therefore the answer will be positive. And if the bigger number is negative, you will see also the answer will be a negative answer. If both numbers are positive, then the answer will be positive. If both numbers are negative, the answer will be negative. If one number is negative, but the sign, it will take the bigger number. And that's what we have just summarized now. And also the same, we always take the bigger number sign. What happens when we apply the basic operations of multiplication and division? Different story. So there are simple rules that will help you when you multiply negative numbers. So one of those rules are And they also apply for the division. So if you are multiplying or dividing, the rules works the same. If there is one negative number, then the answer will be negative, because if you multiply a negative number and a positive number, the answer will be negative. Even when you are dividing, if the number is, if you divide a negative number with a positive number, the answer will be a negative. If the number are negative, then if both the numbers are negative, then the answer will be positive. What does that mean? It means if you have both numbers at negative, it means multiplying a negative and a negative, the answer will be a positive. And if you have more than two numbers, let's say, for example, if we look at this, I have -2 multiplied by -2 multiplied by -3 multiplied by +4. If the numbers are an odd number of negative numbers, then the answer will be a negative, because that will be positive, that will be negative, and negative times a positive will give us a negative. So there are three negative numbers, therefore the answer here will be a negative, because of if I multiply the first one, -1 times -2, it will give me a positive. A positive times a negative, it will give me a negative, and a negative times a positive will give me a negative. If I have even numbers of negatives, the answer will be positive, and I don't have to explain more onto that. So multiplying a positive with a positive, it will give you a positive. Multiplying a negative with a negative will give you a positive. Multiplying a positive and a negative, or a negative with a positive, the answer will be negative. When we work with math as well, there are other properties that you need to be aware of. And those are the 4 properties. So we're going to look at only 2, I think, for now. There are distributive law, commutative law, and associative law, and also the identity property of 1 and 0 that you need to be aware of when we work with integers or we work with any of the numbers. It's the same as when we commute. When we go back and forth from work, we interchange. You can go this way or that way and that way. But the thing is, you still use, or is the rule or the property is still the same. It means you're still going and you're still coming back, even though you change your routes. So let's see how we apply the same logic with math. So if, let's say, I have x plus y is the same as y plus x. Nothing different. So you can also just interchange them like that, because they mean one and the same thing. X plus y is the same as y plus x. In a commutative property, if I have x plus y equals to y plus x, you can write it as such, because x plus y is the same as y plus x. It also applies when you are doing a multiplication. And all this, you are going to see them when we do the exercises, especially. For example, if we look at multiplication rule or law, it says x multiplied by y will be the same as y multiplied by x. And this kind of scenarios, you will see them in many cases, because, for example, when you're solving your problems, let's say, for example, your answer is AB, but in your options in your book, the answers are BA. So you just need to swap them around. so that they mean one and the same thing, because x times y is the same as y times x. A and B is the same as B and A. And you will see when you start working with numbers or with solving problems in your module, you will end up with things like this, where you can just swap around the values. This is different where if we have plus y there, they mean different things. You cannot swap them around. You cannot take x onto this side and move y next to the y. You cannot do that. They mean a different value. Only applies for the multiplication and when you are adding two variables together. So let's say for distributive property, we have A times B plus C. What does that mean? It's the same as A multiplied by B, because we have to remove the bracket. A multiplied by B plus A multiplied by C. So you're going to take A and multiply it into the bracket and also multiply it there, but also remember that there is an addition there. And that is the basic property of working with natural numbers, especially when you look at the distributive law. And if I look at the commutative law for addition and multiplication, remember we said it doesn't matter. A times B is the same as B times A, and A plus B is the same as B plus A. Now, before we even go further and unpack how we work with these values and with these numbers, we first need to also understand the following. When we get an answer as a rational number, then we start applying what we call a rounding off. And rounding off is just the process of reducing the values. So how do we then reduce the numbers of a decimal? For example, the rule states as follows. If, and this is only applicable for this module, if you're going to do things manually. These days, those who have financial calculator, the calculator does the calculation for you by pressing the setup function and checking how many decimals you need to place your calculator, only for the financial calculation. But those who are using, for example, like the sharp scientific calculators or the Casio calculators, you will have to round off your values manually. So if the value to the left or to the right is bigger or equals to 5, then we increase the value to the left with 1. Let's say, for example, I have 1,2246, and I need to only round it off to 3 decimal places. Rounding to 3 decimal places, the value to the right of 3 decimal places, I must look at that value, which is equals to 6. If it's bigger or equals to 5, I must add 1 to 4. So then the answer will be 1,225 because I'm adding 1 to 4. And that's how I reduce the numbers. If the value to the right is less than 5, then I must do nothing. Example, 2,4223. If I round to 3 decimal places, the value to the right is 3, which is less than 5. Less than 5, so I do nothing. So then the answer will be 2,422. And that's how you run off. Remember the following and take note, because you will need to remember this for the rest of the module until you go write the exam. Do not round to an integer unless you are asked. What is an integer? We said it. An integer is a whole number. It's like 1, 2, 3, 4, 5, 6, 7, 8. And if they ask you, round it off to an integer, it means they want you to round it to a whole number. And when I say unless you are asked, you will know, because the option on your answer sheet or on your option on the answers, it will be in 3 decimals, in 2 decimals, and that will be your guide to tell you how many number of decimals you need to leave your answer at. The other thing that you need to be aware of when you start working with numbers and you start solving problems, do not round off while you're still in the problem mode. So it means while you're punching things on your calculator and writing down the answers on a piece of paper, do not cut down the decimals. Write the whole number out, and until at the end of your answer, when you are getting to the final answer, then you can round off to the decimals that you need. Later on, when we do financial math, you are going to use interest rates. Interest rate, you do not round off. So if your interest rate is 7.15%, because we're going to divide that 7.15 by 100, when we divide by 100, that answer becomes 0.00715. You leave it like that and you work with it, and you only round off the answer for your solution that you are looking for. And when we are working with financial math later on as well, when working with money, you always need to remember the following. Money is always to 2 decimal places because it's in cents, rands and cents, and we only write it to 2 decimal places. And like I explained, an integer is just a whole number like 1, 2, 3, 4, 5. And with that, any questions? And if there are no questions, you can do the exercise.
Hi, Lizzie. It's Yolande speaking.
Yes, Yolande.
Lizzie, can you go back to the distributive law slide? Maybe I don't understand that particular slide. Yes, that's the specific one. I don't understand why it's AB plus BC. Because are you not multiplying the A with the B and then the A and the C with each other?
Oh, yes, this is a mistake. So this
Is it a
supposed
mistake? Okay, I just wanted to make
Sorry,
sure.
my bad. Typing error there. So this
Okay.
should be
That should be AC. Okay.
Yes, AC.
Okay, thank you very much.
No problem. Any other questions? If there are no questions, you have A, B, and C questions to answer. And I think the thing is recording. And are we done? It should be quick. Okay, let's have the answers. Answers? Are we still busy? You can also post them on the chat if you are able to post on the chat. Okay, so anybody who wants to volunteer to give the answers?
Yes, Lizzie, it's Rian.
Yes. Yes.
A is 4.578. B
4.578. We were rounding to 3 decimals.
yes, because the fourth number is a 4. It's not a 5.
Yes. The number to the right. Yes. And B?
B is 10.50. The third number is a 5, so you add a 1 to the 9, which makes it 10.50.
Yes.
C, round to an integer, that's a whole number, so the off the comma is a 8, so we add a 1 to the 9, which makes it a 10.
And that becomes a 10. Those who did maths before, you remember that we will go to the last number and we start rounding off from the other numbers. But for the purpose of this, we use the rule that we have. On your calculator, it will calculate and does the correct rounding off as well. Okay. So we spoke about the priorities earlier, but we didn't say what those are, especially when we were doing the cumulative property law. Now, we apply priorities because when we work with the basic operations of addition, subtraction, and multiplication, sometimes they appear in the same question or in the same equation. So we need to find which one we need to do first. And that is why we use the order of operation, which is the BODMAS rule. And with the BODMAS rule, it says brackets first, powers or exponents, division and multiplication, and division and multiplication have the same priorities. So since they have the same priorities, when they appear on the same equation, we work from left to right. You must always remember that. So it means we're going to work from left to right, whether multiplication comes first and division comes last. As long as there is division and multiplication, we work from left to right. Similar, then says addition and subtraction. They also have the same priorities. If they both appear on the equation, we work from left to right. But division and multiplication comes before addition and subtraction. So you first do the brackets, then you do the powers and exponents, then you do multiplication, then you can do your subtraction if those are in your question. But if you have division and multiplication, they have the same priorities. If both of them are there, you work from left to right. Okay, I've touched on this earlier on. I'm not going to go through it again. Just to remind you, negative and negative makes positive. A negative and a positive makes a negative, and a positive and a positive will give you a positive. Now, if I have this equation, 5 plus 40 divide by into bracket 5 multiply by into bracket 12 divide by 3. I need to apply the BODMAS rule. And if I look at 5 multiplied by into bracket, this is my cumulative distributive law that we just did, where I need to take this 5 and remove the brackets with it by multiplying across. But what does the BODMAS rule say? It says brackets comes first. So I need to make sure that I remove the first bracket. Oh, sorry. I must remove the first bracket first. So if I remove the first bracket, then I'm left with equals to 5 plus 40 divide by, I still have my bigger bracket, 5. I don't even have to put the bracket again because I am removing it. Multiply by what is inside the bracket. So by removing the bracket, the inner bracket, I must remove what is inside the bracket. And what is inside the bracket is a division. So I must say 12 divided by 3, which is equals to 4. Then I still go back to my BODMAS. BODMAS says brackets first. So I must remove this bracket that I have. 5 plus 40 divided by 5 multiplied by 4 is 20. Going back to the BODMAS, I have an addition and I have a division. Division first, addition last. So it means I must do the division first. 5 plus 40 divided by 2. So 40 divided by 20. Which is 2, and the answer is 7. And that's how you do the BODMAS rule. Any question? If you had the powers, you will have to resolve the powers first. Any questions? If there are no questions, there is your exercise. A and B.
Hi, Lizzie.
Hello.
It's Ashley here. Can we just
Yes.
address also Elisma's comment there on the right? I see she raised her hand before, but she took it down now.
Oh, okay. The hand, did you want to say anything?
Hi, Lizzie. It's Elisma here. I'm not sure if you can hear me. I just had a comment on the exercise that we did.
With the rounding off.
Yes, with the rounding off, I just typed my query because everyone said 4.578, and I think it should be 4.579 if you apply the rule from the right-hand side.
Yes, sorry, wait. I said also, remember, I said for now we're going to apply the rule that we have in front of us. It says the number to the right, if it is greater than or equals to 5. Can I also plead with everybody else? If we are on this section and I ask if there is any question and I don't recognize you, it means I'm not seeing your hand because my screen is full on the page, so I can't see your hand, and my phone is on the chat, so I can only do two things at once. So please raise your voice so that we don't move forward and then so that we
Okay.
and then we come back. So if we apply the same rule, yeah, it says the number to the right, if it's greater than or equals to 5.
Okay, but even if you put it in your calculator, then
No, that's what I did also mention that when you do it on your calculator, it will do it right. So what I'm trying to prove
yes.
here to show you is you need to always remember when you round off the number to the right, if it's bigger than or equals to 5, then you add 1 to the next. And I did explain it in that way as well. Yes.
So then my answer will be correct.
Yes. And I said on your
Okay.
calculator, it will give you the right answer.
Yes.
But for the purpose
Okay.
of the exercise and for you to always remember, we're going to do it that way.
Okay. No, thank you. Now I understand.
Thank you. Okay. AB. When you have the answer, you can just post your answer. And those who agree with your answer, you don't have to post also yours. You can just press the like. But if the answer is different from yours, you can post yours. Okay, I see all the answers are here. Okay, who wants to go ahead and try and answer the question? Nobody? Anyone? Okay. Seems like I'm alone here. So
Okay, Lizzie, I'll maybe go for the first one.
okay, let's go for the first one.
Okay, with the first one, you have to do your brackets first. So it's 4 plus 7 equals 11.
So it will be 18 minus
It's 11.
11
That will 18 minus 11 will give you 7.
will give you 7. You can, since you are the one who unmuted yourself, you can go on and try and answer the second one.
Okay, the second one, you say 60 minus 20 will be 40. Divide by
And then
divide by 2 plus 6. So then you do again your division will be 20 plus 6. And then 20 plus 6 will give you 26.
and give you 26. And I think almost everybody has it right, except Olga has B as 8. Olga, have you seen where you went wrong? Okay, and that is the first thing we do. Now we're going to move into looking at how we do powers and look at the rules on powers as well. So what are the powers? A power is an exponent, or is a short way of writing something multiplied by itself again and again. For example, if I have 2 multiplied by 2 multiplied by 2, 2 is multiplying itself 3 times. The shorter way of writing it is just to say 2 to the power of 3. And that's what the powers are about. So like, for example, there I have 3 to the power of 2. Our 3 is what we call a base, and 2 is what we call a power or an exponent. There are rules that govern us using this, especially when we do multiplication and division of powers. Adding and subtraction works totally different. So what are those rules for working with exponents? Let's say we have x and b being our bases and a and b being our powers. So we'll have 2 variables, x and y, which will represent the number like 3, and a and b will represent the number like 2, which will be our power. If we multiply 2 bases that are the same, we only add the exponents. So x to the power of a multiplied by x to the power of b is the same as x a plus b. If we divide 2 exponents with the same basis, we subtract the powers. X to the power of a divided by x to the power of b is the same as x to the power of a minus b. X multiplied by y into bracket to the power. So if I multiply 2 bases and the product of those bases to the power, it means at the later stage you will understand that I think it's in rule number 4. Any number without a power is to the power of 1. And if I look at to the power, I'm multiplying with the power. Therefore, because I am multiplying with the power, it will multiply across all the bases. So to remove the bracket, b will multiply with that power on the base. So the power here is 1, the power on x is 1. So b will multiply with the power. So the answer will be x to the power of b multiplied by y to the power of b. And in rule number 3, it says the same thing as I have just done previously. X to the power of a times the power of b, or x to the power of a to the power of b. To remove the bracket, I can just multiply the powers together. So it will be a multiplied by b. The last rule, it says, if I have a fraction to the power of b, so this is the same as x over y to the power of b. They mean one and the same thing. X divided by y to the power of b, I can write it as x to the power of b divided by x to the power of b over y to the power of b. X to the power of b over y to the power of b. Why you need to know this? Later on, when we do differentiation, you will also have to remember all this. At the time where we do component where we use or we solve for differentiation, or we cover differentiation, you will need to come back to this and remember that rules or these rules of powers. Please note the following. If A is any number to the power of 0 is the same as 1. But 0 to the power of 0 is the same as 0. It can never move from being a 0 to being a 1. So what does that mean? It means if I have 1 to the power of 0, it will be 1. 2 to the power of 0, it will be 1. 100 to the power of 0, it will be 1. Any number without a power, like I did with rule number 3, any value without a power is the same as to the power of 1. So a to the power of 1, it can still be written as a. X times y, you can still write it as x to the power of 1 and y to the power of 1. Later on, we will do the roots, but not now. After this, we will cover the roots. Now, any number that you can write to the power of a negative, you can write it as a fractional power. What does that mean? If I have 3 to the power of a negative 2, I can write this as a fractional power. Same as 1 over 3 to the power of 2. Later on, I'm still going to repeat this. When we do differentiation, you will have to come back to this note and these rules that we are applying now, because it is very important to know how to convert a power of a negative to a fractional number. Or if they give you a fractional power, you need to know how to convert that to the power of a negative. A negative number in this instance, just the negative number is this 1 over. So your negative in this instance, it represents 1 over, because everything else stays as it is, 3 to the power of 2. Any number to the power of a fraction, you also need to remember, any number to the power of a fraction is the same as a root. You can write it as a root. Later on, we will cover the roots, like I said. So if I have a to the power of 1 over 3, I can write it as the cube root of a. Therefore, it means 1 over is the caravan, the root sign, and 3 goes to the power. Even if you have 1 over 2, it will still be the root of a. It will mean 1 and the same. If I have a to the power of a half is the same as the root of a, and we're going to cover this just now. On your calculators, I am going to demonstrate something now. Just now, I'm going to open only the one calculator, which is a sharp calculator. Otherwise, then I can also open a Casio. Just give me a sec. Don't think that is a Casio, but we can try. Just want to show you something. On your calculator, there is an x squared that calculates your power. So if I have 3 to the power of 2, It's 3 to the power of 2. You can see there it will write it 3 to the power of 2 or 3 to the power of. Always to get the answer, you press the equal sign. Now, what if it's not 3 to the power of 2? What if it's 3 to the power of 6? 3 to the power of 6, we're going to use this button here, which is y to the power of x. If you press that, you will see that it will create a thingy at the top, but different calculators, different views. If I put the 6, you will see there is 3 to the power of 6, and if I press equal sign, it gives me my answer. So that is to calculate the square. That is to calculate any number to the power. This is to the power of 2, any number to the power. On the Casio, works the same. Sorry, I think you are not seeing what I am seeing. My bad. We need to share my screen so you can see what I am talking about, because you guys are not saying anything, and I realize that I am talking to myself. So this is a sharp calculator. If you see, there is x squared there, and there is the power of an x. Now, different calculators, those with a financial calculator, all these buttons that I am demonstrating on your calculator, they are on GEPR. Yes.
Elizabeth, I still can't see anything. Okay, now there we go. Thanks.
So those with a financial calculator, the x to the power of y is on DEPR. You press the second function first before you press the yx. The x squared is on a dot button. I'm referring to the x squared button, which looks like this. It's on your dot button on your financial calculator. You will have to press the shift or the second function first. So let's say I want to do 3 to the power of 2. 3 to the power of 2, it will give me 3 to the power of 2, and I press equal sign, and that will be the answer. And 3 to the power of 6, and if I want to do 3 to the power of 6 is 3 and to the power of 6, so you'll have to press the XY and then press the 6. So those with a financial calculator, you will say 3 and say second function, and you will press the DEPR button and you press the equal sign, or 6 and then the equal sign, and it will say 3 to the power of 6 is 729. On your Casio calculator, if I want to calculate, so this looks exactly like your Casio calculator, those with the fraction calculator that has this thing. So to calculate 3 to the power of 2, 3, and there is an x squared button there. You just press the x squared and you press the equal sign. There is also this x with a blocky. So this is to calculate any number that is not an x squared. So you just say, you press the cancel, say 3 to the power of 6, you press the blocky and it will create that. And you press 6. You must remember to press the close bracket as well and say equal, and you will see that the answers are almost exactly the same. 729, 729. So you need to know how to use your calculator to do all this. Okay, so that is nope, not you. Yes, you. That is your calculator on powers. However, I have your exercise. Number 1, 2. Just let me do those 2. I must take it back to a presentation mode. Only number 1 and number 2. And I've put there the same note that we had previously. Just do those 2. Only those two for now. And when you have your answer, it might be very difficult to type it on your phone, those who are watching on the phone, but if you are able to, you can post your answer as the way you want to post it. It doesn't really matter. And if one person has posted their answer, you can just say agree by putting the sharp or the like thumbs up. You can thumbs up their answer. It should be easy and quick. Right. And I see your answers. So, okay, I'm going to do it for you, and then the next exercise you are going to do it yourself. Okay, so if we look at rule number 2 for this one, because it's a division, it says if we are dividing, if they have the same basis, then we just subtract the power. So this will be a to the power 6 minus 3, which is the same as a to the power of 3. And this one is rule number 4, which just says x to the power 4 multiplied by 2, which is the same as x to the power of 8. And in your own time, you can do those exercises that are there. Okay, now we move to the root. I didn't think that the session will go as fast. Normally the sessions are 2 hours, so with 1 hour, 30 minutes, it makes it difficult to do exercises and cover everything you want to cover in one slot. Okay, so let's look at the root maybe for 5 minutes, and then we move to the ratio and proportion. A root is the reverse statement of the power, unless there is someone, is there anyone who has a question before we move? I didn't check. Okay, no questions. Okay, move to the root. The root is a reverse statement of the power, like we already did when we looked at the node, and the root is denoted by that root sign. Any number any value with a square root of 2 in front, we can write it as just the root, and we know that is to the power of a half, the power of a fraction half. So if we have a cube root of a is the same as a to the power of 1 over 3. Since we know that a root is a reverse statement of the power, so if we need to calculate the root, and a root says, what is that number that when I multiply that number by itself 2 times, because this says the root sign, and in front it has a 2 or it doesn't have a 2, it will tell me that it's a root sign. So if I multiply the number by itself 2 times, it should give me the root, the 25, the number underneath the square root. And that number is 5, because I know that 5 times 5 is equals to 25. If I need to calculate the cube root of 125, say, what is that number that when I multiply that number 3 times by itself, it will give me 125, and that number is 5, because 5 times 5 times 5 is 125. So how do I then calculate these roots on your calculator? Going back, I need to calculate the cube root of 8 on my calculator. Calculating this cube root of 8. Remember the calculator. I hope you are able to see the calculator right now. Let me see. Nothing is appearing, and there is the calculator. So the root is that one. It's the caravan there. And the cube root on this on the sharp calculators is with the root sign. So those who are using a financial calculator, your root is on button number 3, and the other root is on button number bond, which is a root with a so I lost my pen. So there is a there is a root with an X in front. It's on bond. It's written in orange, so it means we're going to press the second function first when we get there. So how do we then do that on a sharp calculator? So we want to calculate the root of 8, the cube root of 8. So we say the cube root, so it's that function. So we first need to tell what root we're going to be calculating. You press the 3 first, then you press the second function. So those with a financial calculator, you will be pressing second function and you press bond. So in this instance, I'm going to press the XY, and you can see there it puts the root on top, and it tells me I can put anything I want underneath the root sign. And because I'm looking for 8, I'll just put the 8 in there and press the equal sign. And you can see there it says the root of 8. On your Casio, it will work the same. On your Casio, to calculate the root, there is the square root, and on top of the square root, there is a cube root, so it makes it easier, but there is also the root with the blocky, one shaded and one underneath the root sign. So we'll use that one. So we're going to say, so on your calculator, it's easy because you can just go and say second function and press there, and it will give you that. So, but we don't want that. Delete. Usually it gives you the blocking. I'm going to use that root sign. So shift, the root, and it says the cube root, and I'm going to use 8 and close bracket and say equal. And there is my root sign. And if I look at both of them, I should be able to get the same answer. And that's how you use your calculator to calculate the root sign. Take it back. Your exercise. Simplify the following expression. The root of 36 x squared y to the power of 4. It has powers, it has the root. The best way to do this is to split the answers. So you're going to say equal, and you press the root of 36 and the root of x squared and the root of y to the power 4. Now when you have that, the root of 36, you can go to your calculator and calculate it, and calculate that. Because the root of 24 on your calculator, I'm going to use the Casio one. I must out. I'm going to keep, and I open the Casio calculator and calculate the root of 36. So the root of 36, close bracket, equals, and that is equals to 6. Coming back, and that is equals to 6. Now what happens here? I can remove the roots because I know that the root sign is x to the power of 2 times 1 over 2 because I'm removing the root sign, and the root is to the power of a half, and we do the same here. Y to the power of 4, and if I remove the root, it will be to the power of 2 because I'm removing the root sign. And then 6, 2, and 2 will cancel out. We will be left with x. And this is where the fraction comes in. But in this instance, 2 and 4 will cancel out, and 2 goes 2 times 1 is equals to y to the power of 2. And you can even see which one is the correct answer from there. Any questions? If there are no questions, then we can move on to the proportions. Any questions? Let me go check on the chat as well. Nothing? Okay, you happy? No hand? No hand.
Hi, Lizzie. I just want to understand. How do you know how to split what it is under the root?
How do I know how to split it?
Yeah, what goes into what? Like what is put together in terms of our iterator 36 and then x2 and then y2, y4.
Yes, because what I know is 36 multiplied by x squared multiplied by y to the power of 4, which means I can still separate them because this is still 36 multiplied, this is still the square root of 36 multiplied by the square root of x squared times the square root of y to the power 4, because then everyone can be on its own but multiplying as well, because this is a multiplication.
Okay, so if it's phrased or put like this, you're going to assume that, or you're going to correctly assume that it's always going to be multiplication unless it's otherwise stipulated under the root.
Yes, so otherwise they will put another basic operation there. So as long as it's a value, as long as it's something like this, xy means multiplication.
Okay, got it. Thank you.
Right. Okay, so now let's go to the ratios and proportions in this minute. So what are the ratios? A ratio is a way of comparing two or more numbers. For example, it is denoted by 1:3, 1/3, or 1/3. And that's how we write the ratio. Let's look at this example. A company hired 3 females and 21 males. If we want to calculate the ratio of females to males, so especially when we talk about ratios, the minute we mention the word 2, we can assume that the first part of the question, it's if we have a fraction, it's the one that goes at the top, and the second part of after the 2 is the one that goes to the bottom. So if we need to calculate the ratio of females to males, so we can write it as how many females we have, 3 females, 21 males, so it's 3:21, or we can write it as 3/21. And we can also simplify it because we know that 3 can go into 21, it goes into 3 one times, and it goes to 21 7 times. Therefore, the ratio of females to males in this company is 1:7. They hire, for every 1 female that they hire, they will hire 7 males. And we can also even simplify it further, because if we know that the ratio is 1:7, we can also even just go ahead and say how many in a decimal. How many, for every one male, how many females do they hire? So 1 goes how many times into 1 divided by 7 is 0,143. Therefore, for every 0,143 females, they hire 1 male. And that is the ratio. Any questions? If there are no questions, then let's look at how we use the ratio to find the proportions or to answer questions on the proportions. Okay, going back. Yes, question. Nothing? Okay. Proportions. Okay, sorry for that. So a proportion is a simple statement that tells you the ratio of two things, and it helps to make things equal or to make things fair and equal. If we look at this example, Neo and Lebu sells hair products for the total profit of 50,000. The profit is shared according to their ratio of number of products that they sold. Lebu sold 15 and Neo sold 32 products. How much should each receive? So to make things fair, the profit that they made is 50,000. Lebu sold only 15 and Neo sold 32. So Neo worked so much harder. Therefore, Neo deserves to get more profit than Lebu. To do that, we need to first calculate the ratios. So to calculate the ratio of Lebu, we first need to add the total product because we need to add it to the total pool. So we take the ratio, we calculate the ratio of Lebu to the total products that they have sold. Lebu sold 15 to 47. 15 plus 32 equals to 47. So we calculate the ratio of Lebu, but we have to also multiply it with the profit so that we are able to find out how much profit Lebu will receive. And Lebu will receive only 15,957. And we do the same for Neo. We calculate the ratio of the number of products Neo sold to the total and multiply that with the profit so that we can see how much profit Neo will receive. And that's how you use proportions. Any questions? If there are no questions, so now you can answer some of the questions in your assignment, but I don't know what kind of questions they asked in your assignment. And I'm not also sure whether the classes will continue, because tutorial sessions can only continue once UNISA has activated me as a tutor. This, I am just doing it out of my heart as part of the Acolyte program. If there are no questions, I just want to go back to the original slides that we had.
Hi, Lizzie.
Yes.
Ashley here again. Thank you for your kind heart. It's appreciated. Can you give an example of 3 or 4 ratios to each other, like A to B, B to C, C to D, and how that is determined?
Okay, let's do it this way. If I can get quickly into my queue. I hope one of the questions might be on the air. Let's see. Can we find a ratio question? I doesn't seem like I'm looking for at least one example of that. Not finding one there. Okay. Maybe probably this will help. So for example, is this what you're looking for? Something like this. I think we have a couple of them. For example, like this one, where we have a ratio of 3:4, 1/2, but now this one uses fractions. So let's go to the one that it doesn't require fractions. Let's use this one. So a certain school has 1,800 learners. The ratio of number of boys in a school to the number of girls is 5:4. So we know that the ratio of boys to girls, so 5 is boys and 4 is girls. The total will be 9 respectively. So if we want to find out how many girls are there in the school, we'll have to find the ratio of girls. We know that the girls are in the 2, so it means it's the second part of the ratio. So we need to calculate the ratio of 4 to 9, but also multiply it with 1,800. And that will give us 4 divided by 9 equals multiply by 1,800. Give us 800. So there are 800 girls in that school. And the same will apply with this. If you want to use, you can, when you get the videos after the session, they will pop up in the chat as well, I think, or they will be posted on my UNISA, so under the Western Cape region site. So you will be able to see the video. So you can go and answer this question. You can pause the video and answer the question. The other exercise I'll just leave it for a sec so that you can pause the video when you get to that and do that exercise. All this calculates the ratio. So how many liters of wax are required? You will have to calculate the ratio of wax. So wax is the first one. So therefore this is the wax. 3/4 is the wax. So you will have to find what is your proportion of wax. So it will be that to divide by the total. So you'll have to add all of them and then multiply by the liters. So you will take this, divide by the total when you add them. So since we have not done the fraction, those who know maths, they will find it easier because they will just use the fraction knowledge that they have to answer this. That's why I'm staying away because time is up. And this also tells you the ratio. So these are the kind of questions you will get as well in the exam. And this is also one of the ratios. You will get the question like, what is the ratio of 250 to 1? Remember, the ratio of 250 to 1 will just be 250 divided by 15. And you can find how much 15 goes into 250 and so forth. And you will just convert it. Okay, any other question? And if there are no questions, I need to wrap up. Cut and go back. Let's recap, and I will give you some other information that you can use. So far, what we have learned, we learned how to work with numbers. What are the types of numbers are there, like your integers, natural numbers, irrational numbers. We learned how to work with the BODMAS rule. When we work with some of the basic operations, we apply the BODMAS rule, how we look at the powers, and how we look at the roots. And now, lastly, we looked at the proportion. If you need to get in touch with me outside of this, there is a WhatsApp group. Oh, first, there is an email you can use. That's my email. There is a WhatsApp group that you can join. If you type that link on your phone web browser, exactly as you see it, don't use small letters where there are no small letters. Don't use capital letters where there are no capital letters. So the same way as you see it, http://bit.ly/QMI1500 dash, there is a dash, not underscore, the dash one, paro in capital letters. It will take you to the WhatsApp group. So you can join that WhatsApp group. Any discussion after this session, any help with assignment, I am not sure if I will be able to help you with the assignment at this point, but today I might find time, but tomorrow, because I work 9 to 5 job, so I might not during the day, but in the afternoon, I might have time. If you need notes, my notes don't change. They are the same. So all the notes are there. You can download them. I have, since last semester, I tried to do some of the videos to help students. So some of you might not be aware of these videos because I only share with the video in my first session and then I stop. So these are all YouTube videos, but you can access them from the site that I created. The session today is recorded, so the video will be shared on my UNISA under the Western Cape Paro region. They will send you the link if you haven't received the link yet. You will get the link. You will get the link, and on those videos there will be the notes for the session that we just did today. I will post it there so that it's accessible as well for you to download. With all the exercises that are in there and those that I haven't covered as well that you can go through on your own. Otherwise, thank you guys for gracing me with your presence today, and I hope and pray that even next week we can have a session And that's it from me. Enjoy the rest of the week, the evening and the week.
Thank you, Lizzie. Have a good evening.
Thank you, Lizzie. Bye, everybody.
Bye.
Thanks, Lizzie. I appreciate it.
Thank you.
Thank you. Bye.
Bye. And those who haven't signed the register, please remember to sign the register, to complete the register before you go. The link is there. I forgot to.
Night. Bye. Nice. You know?
Huh?
This is,
My class is finished.
this is better than wasting money and going to unis and driving at night because
Let's just continue online.
this is perfect. Yeah.
So easily.